Hello and welcome to Hopkins at Home. Thank you for joining us today. I'm Sayeed Choudhury, the Associate Dean for Research Data Management and Head of the Open Source Programs Office here in the Sheridan Libraries in Hopkins. Today I'll be talking about the open source software revolution, starting with the basic primer about open source software, and then progressively making the case that open source as a way of cooperation has the potential to address some of the biggest challenges of our time. I would encourage you to ask questions throughout my talk using the chat module. I do intend to leave time at the end to address some of your questions. So with that, let's jump right in to a definition of open source software. This is probably the most common definition you might see if you were to search around on the web. And very often when people talk about open source software, they think about licenses, and that's an appropriate way of thinking about it. As you can see from this definition, it's really about licenses that convey rights to the users from the copyright holders to use, study, change, and distribute not only the software, but the underlying source code itself to anyone for any purpose. Now, there are a lot of licenses that allow people to use software, but it's that idea of being able to study it, change it, distribute it for anyone for any purpose that really defines open source software. This might seem like a fairly radical idea. I can literally go and look at someone's source code and I can learn about it and study it and modify it and adapt it. But that kind of way of working actually reflects the way the early principles of the internet and the web, at least the designers of the internet and the web had in mind. So it may seem a little bit unusual in the terms of software, but this is something that's been a design principle, if you will, for many decades. It's possible for anyone to produce software and then deposit it into some sort of software code repository. But in reality, what I'm describing there of a single individual working in that way and then hoping that there is some interest or adoption or engagement is what we would call open code. Moving toward open source software really conveys that there is a community of developers who work in intentional and understood ways to contribute, manage, resolve issues around the software and update it and distribute it. And also that there's a community of users who have very clear ways of providing feedback that get incorporated into the development pathway as well. So it may seem like if you have individuals just doing work on their own, it might be somewhat chaotic. But open source software, not only in addition to the license, it not only includes that, it also conveys that sense of having some sort of structure, some sort of community that allows people to participate in the development. There is a group known as the Open Source Initiative that in many ways is the steward of these licenses. You can see the page from their website that show these licenses. I am not a legal expert, but I did have the pleasure of hearing from Justin Colanino, who gave a talk at Hopkins. He is the Senior Corporate Counsel at Microsoft. And he talked about basically these licenses have different levels of permissiveness. So some licenses are very permissive in not only adhering to that definition, but also you can use the software for commercial purposes, maybe even encourage that kind of use. Whereas other licenses may be less permissive, actively discouraging commercial use or making it difficult or maybe even prohibiting it. So there are choices you can make in terms of the licenses that you have. As I mentioned, they give these sort of different levels of permissiveness, but they're all open source licenses. It's really important to note that the reality that these licenses exist and that there's an organization that acts as a steward for them is a differentiating aspect of open source software as compared to open articles or papers or open data. And that's a point I'll come back to as well. So if you use the Mozilla Firefox web browser, you're using open source software. And if you use the Google Chrome browser, while the browser itself is not open source, the underlying platform known as Chromium is. And regardless of how you might browse or access the web, the underlying engine, at least initially for the web, was open source. There's something called the Apache Web Server. So it's at the heart of everything we do and every way we use the World Wide Web. The Linux operating system for computers and servers is an open source platform as well. Google's Android mobile device operating system is also open source based around the Linux operating system. Apple's Mac OS and iOS for their computers and their mobile devices is not open source, but it actually uses a fair number of open source components. And for those of you like me who continue to use email, it's important to note the early email applications like SendMail were also open source. So fundamentally, no matter how you gather information or access the web or communicate, whether it's through a browser or a mobile device or email, you're using open source software. And in the corporate setting, moving from the individual to the corporate setting, there are hundreds of companies that now use open source software. Virtually every Fortune 500 company uses or creates open source software. And it's not just technology companies, the Googles and the Microsofts of the world you might think of, but Walmart, American Airlines, US Bank, healthcare providers, and all of these companies are now using or creating open source software. It literally affects every aspect of your life. It is the new substrate through which we build tools, utilities, infrastructure, services. Companies now think of the automobile as a computing platform. So it's literally everywhere. There's a group organized under the Linux Foundation, which is an industry membership organization focused on open source called the To-Do Group. And this is a group that's brought together these companies that focus on open source through what are called open source programs offices or OSPOs. And the To-Do Group began by looking at engineering practices, legal issues, compliance, license choices, software dependencies, supply chain, things of that matter. And is progressively starting to think about it more broadly, but really in many ways gave us a blueprint for this open source program office or OSPO, as we like to call it. A little sense of global impact. One of the most recent studies about the impact of open source software came out of the European Commission. And you can see the numbers here, tens of billions of dollars, hundreds of billions of euros with additional investments, and the creation of small businesses and jobs as well. So workforce development is another important part of open source software. It's worth noting that the European Commission has recommended the creation of 20 of these OSPOs in universities and municipalities, which is another way of being intentional and organized, having centers of competency and excellence around open source software. So moving from this global context to a more local context, the work of open source software and the OSPO at Johns Hopkins literally began with a conversation between Jacob Green and myself. Jacob is also a fellow JHU alumnus. He's a member of the CS Computer Science Advisory Board. And I received an email message from a mutual acquaintance saying, you know, I think the two of you should talk. This was Stephen Ruckman, who was in the president's office at the time. And we had a long, wide-ranging conversation about lots of different topics. But the fundamental question or premise and question that Jacob put to me was, open source has become a key part of industry, of the corporate sector. It's not just part of their technology strategy, it's part of their overall strategy, and it's impacting everything they do. Where are universities in this mix? And it's somewhat of an ironic question because many of the open source platforms and products and so on that I've talked about, at least in the early days, came out of universities. And yet it seems like universities have lost their connection around open source. And there was a parallel story, if you will, around municipalities and governments, is what are governments doing around open source? So to make a long story short, we launched the first university-based OSPO in the United States. So there were other institutions that were doing work around open source in institutional ways, but none of them had coalesced them into what we call the OSPO. So Hopkins made the decision to create the first university-based OSPO, and you can see the web page for that OSPO here. Now, one thing I like to think of is there are equivalents to OSPOs and things like CIO offices or HR offices. So corporations, universities, city governments, national governments have CIOs, have HR directors, and so on. There's that common foundation of open source, the engineering, the policy, the compliance, and so on, that spans every type of organization. But then there are unique functions as well. Corporations don't have students. They don't have libraries, or generally speaking. So there are all sorts of particular aspects or characteristics of universities where an OSPO can be augmented. The traditional model of the OSPO can be augmented, and that's what we've done. And we've done that by focusing on what I think of maybe 3 pillars of universities. So that's research, education, and translation. Research, I think everyone knows. Education, of course, people know. Translation is really the idea of how does the research and the education of the institution span beyond the walls of the university. And in order to do that, we've created another layer that sits on top of the OSPO. So you can think of the OSPO as the operational entity, if you will. And the Institute for Applied Open Source is where we focus on this research, education, and translation piece of things. One really important lesson that we've learned in the early days of university-based OSPOs is treating software as a primary research object. So you think of articles, and you probably think of data being produced by universities as research objects. And there are offices and infrastructure and people and resources available to support that. Open source software itself is also a research object, and there's far less intentional attention and effort paid to the software as a research object, which in some senses is unfortunate. Again, universities in many ways can take credit for starting open source software movements, but also we can learn a lot more about data by looking at software than we can at articles. What I'm showing in this diagram is, articles or papers on the left. They often cite data, but it's clear that papers and articles are the end of a story of research, of scholarship within an institution. And the data that are cited are often also the end of a large process of using data. They're the most refined, the most cleaned up, the most accessible versions of data. It's by looking at the software that you actually understand much more about the processes by which the data were created, how they were interpreted, how they were processed, how they were shared. Just to give you a data point, I spoke to a medical researcher some time ago, and he said, I don't want to work on any more data use agreements until I look at someone's code. Data use agreements are what we create when we want to share restricted data with parties outside the group that created it, typically within institutions. If Hopkins and Stanford wanted to share data, we typically write a data use agreement to do that. His point was that these data use agreements take a tremendous amount of time and effort, and we can't anticipate every type of use. But if we can look at the code, we can see what people are doing with the data without actually looking at it. And that gives more insights into what you might ask for in a data use agreement. And another point I'll make is that if you had an arrow that went from the left to the right of this diagram, what you'd notice is that the ecosystem and the workflows and the relationship with the private sector change from articles to software. In articles, you could argue these are practices that have been around for hundreds of years and reward structures that have been around for hundreds of years. And there are for-profit publishers who have a very fixed position within this ecosystem. But as you move to data and then to software, all of that changes. So the ecosystem for software is much less mature. The way we work with it is being developed as we speak. And the relationship with the private sector is very different. We created this OSPO at Hopkins. We've been very fortunate to get tremendous help from industry experts, individuals, and institutions to help stand up our OSPO and to create a model for other universities. So the private sector is very eager to work with universities to figure out how to manage and share and empower the use of open source software together. That isn't true when you look at articles of paper or even with data. So I think we have, sorry to use an engineering term, that is my education, more degrees of freedom as we think about open source software than we do with papers or articles. So building off the work that the To-Do group has done, we are part of a group called OSPO Plus. This is very much the definitive network where if you're looking to create OSPOs in universities and governments, civic institutions outside of the industry sector, this is the network and the way of working together and cooperating that's been developed. And we're doing a lot of amazing work by working with this OSPO Plus group. So let me give you a couple of examples of things that we're able to do now that we have this OSPO. One of the projects that my group in the library had worked on is called the Public Access Submission System, or PASS. And fundamentally what PASS does is make it easier for researchers to comply with the requirements of their grants and their institutions to share articles. So it's a system that simultaneously deposits articles into multiple places that you would be required to, or at least encouraged to do so. And on our roadmap is also depositing the data that are cited in those articles. Now, this is a platform that we built at Hopkins, working with the National Library of Medicine at NIH. But we've also, I have an active grant to extend this to other federal agencies. So the ultimate vision is that I can deposit this to multiple federal agencies and to my own institution. There's interest amongst some to make PASS a platform that other universities would use. Every university that receives grants or has an open access policy would be interested in PASS. But they also made it clear that if it's a Johns Hopkins product only, that of course makes it difficult to say Harvard, MIT, Stanford, you should use this thing that came out of Hopkins. So what we've done is joined the Eclipse Foundation, which is another industry membership open source organization, to take PASS and make it a product of the Eclipse Foundation. Now, the license didn't change. We used what's called the Apache Software Foundation license, so that still remains in place. But we're getting tremendous help from the Eclipse Foundation in terms of the engineering practices around making PASS more robust, more scalable, more secure, more usable for multiple institutions. And I would submit that if we weren't working with someone like an Eclipse Foundation or the Linux Foundation, then the federal agencies simply wouldn't have the confidence, quite frankly, to say, you know, we trust you, Hopkins, that you know how to develop this kind of software for an entire community. So this process of working with the foundations like Eclipse has been tremendously educational. I have an incredibly talented group of colleagues in terms of systems engineers and software developers. I'm very proud of the work that we did with PASS and the work they do in other contexts. But I will tell you, we are learning a lot by working with Eclipse in terms of what it means to take software like this and engineer it to work at scale. You know, there's one of the people we've been working with at Microsoft is Stephen Wally. He's this great metaphor to cooking. If I prepare a meal for myself, that should be pretty easy. If I prepare a meal for one other person who I know, then it's easy enough for me to say, does this work for you? Should we eat this today or not? If you prepare a meal for a group of people, you have to ask about dietary preferences, restrictions, so on. And if you cater an event, you probably don't ask every single person what you want, but you have a set of choices and you customize them. And then if you're preparing food for hundreds of thousands of people, it's very different. So imagine the metaphor for software around that. So we're trying to go to hundreds of institutions, thousands of users, and that's something we're learning working with Eclipse. Another project that I want to talk about actually didn't come out of Hopkins, it came out of the city of Paris. It's called Lutes. It is an open source municipal services platform. So it was developed for many years with millions of euros. The CIO's office in Paris is very engaged in supporting this platform. And it provides hundreds of digital services for the city of Paris, things that you and I might do in Baltimore, fill out a 311 request, file for a permit, pay a bill. But it also has some very innovative features, such as participatory budgeting. So 5% of Paris's budget is actually allocated by choices through this platform. There's direct engagement with the citizens of Paris. They propose ideas, they vote on the ideas, and then 5% of the budget is allocated based on that feedback. I think that has tremendous potential, not only in Paris, of course, but in any municipality. So the team at Lutes in Paris is very interested in building a community of developers and a community of users, coming back to that original idea I talked about of what goes from open code to open source software. And Jacob brokered a relationship, quite frankly, with the CIO's office and the OSPO at Hopkins. And we started to work together to think about how Lutes could be deployed across the United States, but starting in Baltimore and starting even more close to a community through the St. Francis Neighborhood Center. So this is a neighborhood center that works, that's based in Reservoir Hill in West Baltimore. Really amazing group of people. I love their mantra, which is, you can see in the corner there, end of generational poverty begins here. This is a community center that has long-term relationships with families, is deeply invested in the families and providing holistic support. And has done amazing work. They are building an expansion to their current facility, their current building, and they will have in there a smart center, a place with laptops, digital capabilities, Wi-Fi, so on. They view Lutes as part of their smart center digital strategy. They want to use Lutes to manage some of the functions they work on. So if you think about Paris, there are civil servants, right, that have to look in Lutes and figure out what work they might have. St. Francis is taking that and saying, we don't have civil servants, but we have volunteers. So are the business rules or the workflows of how you identify work for civil servants similar to what we do with volunteers or hope to do with volunteers? In turn, Paris is now saying, well, why don't we access volunteers? If we figure out this work for St. Francis, couldn't we do that in Paris and not only have civil servants addressing things, but have more organized, intentional ways of working with volunteers? So we are working with both the City of Paris and St. Francis. This is a press release that came out from the CIO's office in Paris about the work we're doing together. And let me make a couple of really important points. So we have a city in Europe, a university in Baltimore, and a neighborhood center in West Baltimore working together. I have worked on enough collaborative or cooperative agreements to know that if we had to sign agreements, this would have taken weeks, months, maybe longer. But what we're doing now is working under the auspices of the Lutes open source license. So when somebody says, what are the IP arrangements? What are the risk profiles? What are the so on? You point to the license. It is a much more frictionless way of working together than having to sign legal agreements or cooperative agreements through grants. We were able to move quickly to actually writing code rather than figuring out how to make the agreements happen. And while we're working with the current features of Lutes, we have ambitions to extend it in really significant ways. Lutes has a so-called plugin architecture. It's got a core base of software, and then you have these plugins for different things, like 311 for participatory budgeting. One of them is to identify available spaces in homeless shelters. And this is a very, sadly, important problem for not only Baltimore, but many places in the United States. And the director at the St. Francis Neighborhood Center told me that typically the way this works now is someone shows up and says, I need a bed for the night. And if she doesn't know where there are beds available, she calls one of her counterparts at another community center and says, do you know if there are beds available, and so on. We can do this better with software. Lutes is a platform where we could basically say, here are the beds that are available, and would you like to actually book one of them? And this is an interesting way of which universities and students can get involved. So a group of students at Hopkins on their own decided to reach out to various organizations, including St. Francis, and ask questions of what I would call requirements for building software. And what they discovered is it's not enough to say, is there a bed available? You have to ask additional questions. As you might imagine, in some cases, people will say, is it only for women? Sadly, does your shelter take kids? Some homeless people have medical devices they have to plug in. Does your homeless shelter have a bed low enough that I can plug in my medical device? You have students spontaneously getting involved and contributing to this effort, defining requirements that will ultimately help us build a platform to do this in a much better and more strategic way. And thinking about Baltimore City, it's a difficult challenge to pose to Baltimore City to say, you need to build a system that makes it easier for people to identify where there are beds in homeless shelters. It's not trivial, but it's easier to say, we have an open source system that you can look at. You can assess it, you can examine it, you can vet it, you can ask whatever questions you have of it. If you manage data from homeless shelters in this manner, any community center using Lutes can do this in a networked and coordinated way. As I said, that's not trivial, but that's a much easier ask, if you will, of a municipal government. So we are finding all of these amazingly innovative ways to work with an existing platform that came out of Paris. It's working with a community center in West Baltimore to do things that are transactional, like paying bills or setting up appointments, to things that I believe are fundamentally important, like helping homeless people not only find a bed in a shelter, but you're now interacting with a system and a group like St. Francis that may be able to help you get on your feet in other ways too. So if I shift from the software sort of journeys to more of an educational piece, the really exciting thing that's coming out of this Institute for Applied Open Source is the semesters of code. And one of the wonderful aspects of Hopkins is that it is the first research university in the United States. And there's a fundamental premise that how you conduct research is the best way to learn education. So when I was a senior, this will date me, in civil engineering, I took a course in steel design, and there was a code that was being written at the time. It was the ASTM A58 steel design code for what I call rebars or reinforcing bars. And our professor showed up. So I went to the bookstore looking for the textbook, and there was none. And when we showed up, we said, "Where's the textbook?" He said, "There's no textbook." And he gave us a photocopy of the A58 code. He said, "We're going to go through this over the course of the semester, and you're going to make recommendations." I remember turning to a fellow student and saying, "We don't really know what we're doing. I mean, what kind of recommendations can we make?" And of course, we weren't directly influencing the code. This was an exercise. But the point of it being, his research was the foundation for the education that was taking place. That's at the heart of semesters of code, is that there are research projects happening at Hopkins, and by learning about them from the software perspective, you can get a really tremendous understanding of software engineering. So it does build upon prior efforts and successes at other universities and through hackathons and Google's Summer of Code. But this emphasis on the software engineering piece of it as it relates to research software is a key differentiating aspect. We are very fortunate to have Stephen Wally, who's a senior executive at Microsoft. He has 40 years of experience in software engineering, teach this course. He taught an intercession course last January. It was very well received. We will be teaching, when I say we, Stephen will be teaching a course in the fall, a semester-long course that expands that idea. And then we imagine that it will become semester-long experiences, hence the semesters of code. So just like an internship in some sense, but it very much resonates with the recommendation that came out of the Q2 report that Hopkins produced for the so-called Hopkins semester. Can we have more semester-long experiences that embed the students in real-world practical kinds of experiences? And that's exactly what semesters of code aims to be. And we're including projects like PASS and Lutes that I just described to you. Semesterly is something that was developed by students at Hopkins. So you're now seeing student projects come into the mix. Open Cravat is a research platform that's been developed by Rachel Karchen's lab and Kim Pagel. And it is an NIH-funded effort. So we are directly seeing that kind of research software come into this mix. And Microsoft PowerShell is a tool that Microsoft produces. So we now have an industry or a corporate project in this mix. So this very interesting diverse set of projects provides the foundation for semesters of code. And we are looking at extending this to work with other universities. And there's actually interest in NIH and other agencies to work on something like this. So I've been focused probably on the sciences and engineering. That is my background, but it's critical for me to point out that this is not only a science or STEM or engineering type of effort. Open source software and open data is permeating multiple communities, multiple disciplines. And I'm very, very honored to be part of a grant that we just received from the Mellon Foundation to work on something called Black Beyond Data. The principal investigator is Jessica Marie Johnson. Co-PIs include Alexandra or Sasha White, Kim Gallen, who's a visiting professor from Purdue, and Jeremy Green in the School of Medicine, and also Tom Lippincott, who's a researcher in arts and sciences. And Jessica has this wonderful phrase about the premise of Black Beyond Data is that we have to trouble the data. And I didn't quite understand what that meant when she first said it, but in essence, there's an assumption that data is objective and neutral and without biases and without values. And that's simply not true. That if we look back at obviously the newspapers of the day and the data that were produced through insurance charts and so on, we need to re-examine those with current lenses to show what biases and what injustices were propagated through that data. And open source software and the OSPO at Hopkins is a key part of that. So we've been involved in not only these kinds of efforts that I described, like PASS, the tests, and semesters of code, but we're now working with humanists who are looking at issues like racial injustice, and not only looking at them, but trying to find ways to address and remediate them. And open data and open source software and the OSPO at Hopkins play a really important part of this. So someone who I admire a great deal is Zeynep Tufekci. If you are not familiar with her or not familiar with the work, I would encourage you to look her up. She's an information scientist at the University of Chapel Hill and was on the Ezra Klein show and talked about systems thinking. And this was her definition of systems thinking, which I think is a very good one. I have a background in systems engineering, so this resonates with me very much. But I love this idea of looking at the whole and looking at the interactions at the same time, how it all comes together. It's not only the whole system, it's not only the pieces, but you have to look at the whole integrated way of doing that. And open source software has at its heart this premise, right? It's that there are individuals contributing, there are modules, but then we have to think about the whole thing. It doesn't really cohere and coalesce into something powerful unless you think of the whole thing as some of its parts. If I go back in time, another person I admire, he's passed away now, Doug Engelbart, is one of the original creators of the internet. If you Google Doug Engelbart, mother of all demos, it's sort of an unfortunate label that's been attached to this demo he did. It was 1968 at the Stanford Research Institute. It is unbelievable to see the vision in this demo. Engelbart and his colleagues demonstrate the mouse, they demonstrate video conferencing, they demonstrate collaborative document editing, and hypertext, the ability to link from one document to the other, the very fundamental premise of the web in 1968. It's just stunning. It's one of the first mentions of ARPANET, which would become DARPANET, which would become the internet. So it's a few minutes, you will get an incredible picture into the early thoughts around the internet and then eventually what would become the web. I heard Engelbart speak at a conference in the late 90s where somebody asked the question to him, you know, when you were doing that demo and when you were working on these things, could you have imagined where we would be, you know, today? And he was silent and he paused and he looked down. He said, I know you're asking a positive question, and I'm sorry if this sounds like a negative or a cynical response, but I'm completely underwhelmed by where we are today. I did not imagine this is what would have happened with what we did. I was working with others to try and augment collective intelligence to work on humanity's biggest problems. And he really felt like we had fallen short in that regard. So let me come to this thought of revolution. You know, who am I to talk about revolutions? Well, what I will say is engineering may not be the best training to talk about revolutions, but both my parents were political scientists, and they had diametrically opposite views in political science theory. And as far as I can tell, it sort of came down to how your assumptions about human nature, about how people behave. It made for very interesting dinner time conversations. And I would often feel left out. I don't think it's a coincidence. Both my brother and I became engineers after these dinner time chats. And I remember once my dad saying, you know, we should, my brother's 6 years older than I am, so he started engaging in these chats well before I did. And I remember one meal where my dad said, you know, we should hear what Sayeed wants to say. You know, we all talk about politics. Well, what would you like to talk about? And I wasn't ready to address that in a systematic way. So I just said astronomy. I was interested in astronomy at the time. And we talked for 10 minutes about astronomy, and then we went right back to politics. So after that conversation, he sensed that I was a little bit deflated, I think. He said, you know, I'm sorry that didn't go the way you thought it would. And I said something to the effect of, I don't understand political science. I don't understand all these debates and so on. And he basically said, I mean, you know, you'll get different opinions. But for me, it basically boils down to how institutions make decisions and allocate resources, and whether we choose to cooperate or not when we do that. And don't forget, institutions are always made up of individuals. This to me resonates with systems thinking. This to me resonates with open source software. So we've just been through a global pandemic, and everybody talks about it as a 100-year event, and it is. But I actually think it's worse than that. In 1918, when we had the flu outbreak, you couldn't say it affected every country on the planet, and COVID did. Now, some countries handled it more effectively than others, but they still had to test their populations. They still had to change travel policies. They still had to do all sorts of things. It's arguably the first time that every nation on the planet had to think about this in an intentional way. I had the privilege of being involved in the team that supported Lauren Gardner and Frank Dong, the J2 COVID map. And that map lists every country. There's data for every country coming into that map. It's also the first time we shut down the planet. In 1918, if you needed food, you didn't go to Instacart or food delivery or Amazon or Whole Foods or Peapod or whatever your choice might be. You went to the store. There was no option. So we've gone through something that's unprecedented. We're now rebooting the entire planet. And I don't know about you, but it doesn't feel like we're returning to normal to me. And maybe it's a new normal, maybe it's not even normal. Ask an economist whether the inflation we're having now is transitory or long-term. You will get answers across the spectrum. So I have a sense that when these types of things happen, we start asking these questions about how we're going to allocate resources and whether we're going to cooperate or not. The big difference, again, is we are much more interconnected than we have ever been before. And the previous CDC director during the Trump administration was asked whether COVID would become an issue in the United States. And I remember exactly what he said. He said, you can't hermetically seal the United States from a global virus. And you could say that for climate change. You could say that for cybersecurity. You could say that for a whole host of things. You could say that for supply chain disruptions. We're not getting things in our stores, in local neighborhood stores, because of issues in other countries. We're not going to be able to hermetically seal individual countries and say, in this rebooting, we're not going to care what anybody else does. We're just going to sit in our isolated bubble because you're too interconnected. And I believe that open source is a way of working together as a verb, not just a noun, with its explicit commitment to transparency, trust, engagement, diversity, partnerships. It's going to be critical. That think about cybersecurity. I heard on Bloomberg News that 85% of oil refinery companies in the United States write their own software. It's bespoke. And we don't know whether they wrote it themselves or asked a third party or know someone, or maybe your family member did it. I don't know. But imagine being asked to go through that ecosystem and vet that they are prepared for cyber attacks as we experienced. And imagine a scenario where you say, you need to use open source software. I'm not telling you what license to use. I'm not telling you what engineering practices to use. I'm just saying it needs to be open, so that by definition, we can examine it and we can query it, and there's a community I can talk to. And there's a way to know that this is in fact the vulnerability, this is the security. Many eyes on the code is a great way to deal with security issues. So this way of what happens when you flip something to being open source, rather than assuming that it's closed and it's isolated and it's insulated. And if I can think about Engelbart's comment about he was underwhelmed by where we were. And the other thing he said is it's too fragmented. We had imagined the web being a collective worldwide type of resource, but it feels fragmented now. What this diagram shows you is a set of components that we're looking at. And Hopkins is playing an incredible leadership role in each one of these components and how they might fit together in an ecosystem so that we don't get a fragmented, bifurcated approach to how we deal with open source software. And that we actually have an intentional strategic way of thinking about this. If you are familiar with TCP/IP, which is the protocol that underlies the internet, back in the day, people were coming up with their own local types of networking protocols. And then TCP/IP came along and everybody adopted it because it was clear. If I can use a protocol that allows me to work globally, why would I have an idiosyncratic local version instead? It addresses both the global and the local context. This is a no-brainer. It's the same as railroad gauge. We had regional railroads that had their own railroad gauge. If you want to get from the Atlantic to the Pacific coast, you better agree on a railroad gauge. And once everyone agreed on that, all the local variants went away. So we have an opportunity to do this in an intentional way that is coordinated, that is global, or we may miss our opportunity and end up having things become bifurcated and fragmented and lead to the kind of underwhelming outcomes that Engelbart talked about. So just a few closing thoughts or remarks. I'm sitting here on the unceded land of the Piscataway tribe, but I'm looking at the wisdom of the Hopi in Arizona. And I'll let you read this quote while I tell a story. This is a true story that was shared with me from the people of the United Nations who are establishing an OSPO as well and have cited the work at Hopkins as part of their inspiration. The United Nations has these open source events where they encourage people to make contributions to UN software projects. And one of the software projects, the UN had worked with a university in Sweden that I'm told is the equivalent of MIT in Sweden. And they built software that allows you to assess impacts to the electricity grid. And the way that this Swedish university built it, the resolution of the grids was 10 square kilometers, 10 kilometers by 10 kilometers. And it took over 20 hours to run through one simulation. So the UN basically said, let's see if we can do better. And they didn't say, we're going to get another university. They didn't say, we're going to go hire a company. They had an open source challenge. They said, come one, come all. Here's the code, here's the goal. Have at it, do what you can. A month later, a single young woman from India submitted code saying, here's my version of it. When they looked at it, they discovered that the resolution that her code was working at was 2.5 kilometers by 2.5 kilometers. So much finer resolution. And that her code took 30 minutes to run through any one of these simulations. They were so impressed by her, they invited her to the UN in New York, her and her father. Apparently met the Secretary General in a handshaking event pre-COVID. And I'm told that when she and her dad left the building, there was not a dry eye in the house. And she said, this is the greatest day of my life. So we can wait for someone else to try and address these challenges. We can look to billionaires going to space, or we can roll up our sleeves and we can address these problems. And there are researchers at Hopkins, there are students at Hopkins that we will want to tap into, but there are young women in India, and there's a kid at St. Francis who goes to the after school programs. And then there are people I cannot even think of who have tremendous talent, have lots of contributions, are the ones we're waiting for, right? And open source is a way to bring them together and to do so in an intentional way that celebrates all of their individual contributions as part of a bigger system. As Zeynep Tufekci might say, Doug Engelbart might say, or my dad might say. And if I can build on what Engelbart had to say, I think the open source revolution will empower and amplify the ones we've been waiting for to augment human intellect and compassion, because I think we're going to need both if we're going to address the big challenges of our time. So with that, I would be very happy to hear any questions or comments that you might have in the time that we have remaining. So I do see one question in here. It says, good resources to keep up with the current events in the open source software space. So there are many resources that one can look to. The Open Source Initiative is one place that I described. The To-Do group is another within the Linux Foundation. I would encourage you to join the OSPO++ calls. If you go to that website, there's a link to join. We are taking a break in the summer for the rest of the summer, but starting up in September, there's a series of conversations that happen on a regular basis. There's a series of resources on the website as well. that is becoming a very vibrant community where you can address those kinds of, or learn more about the open source software space. Do I agree with the definition that a license is only open source if it is approved as such by OSI? So as I said, I'm not a legal expert, but what I will say is that my understanding is the value of having OSI licenses that are approved, if you will, is we don't have a proliferation of licenses, and we don't end up having very specific licenses for very specific cases. If you look across that spectrum of licenses that are there, it really covers a lot of what I would call use cases or sort of scenarios. And this is what I was getting at in terms of when it comes to articles or data, we don't have that. And even the federal agencies have struggled to define policies because they keep waiting for institutions to come up with policies. We have the advantage in the open source software world that these licenses exist, that any institution or any federal agency could come along and say, you don't need to reinvent the wheel. It's already there. You already have these kinds of licenses. You as an institution, we as an agency saying this is the approach we think is relevant. If there is a gap that exists, then I would submit the best thing to do is work with OSI in essence and say, I've looked through the licenses, here's a case I have. Maybe it is truly a so-called edge case that no one's thought of or no one's addressed the licenses, but I would still encourage people to work through OSI. So the next question I see is, how should we be thinking about the inevitable cyber threats of open source vulnerabilities? Do open source softwares present any security concerns? So I guess I would say that any software has security concerns, whether it's open or closed source. I cannot imagine someone producing software that is so fail-safe that they would say, I can't see any issue at all. Some years ago, I was in a meeting organized by NIST where I met a so-called white hat hacker, someone working for the government who addresses security vulnerabilities. And I'm probably not getting his exact phrase right, but he said something to the effect of, I can break into any software I want, do whatever I want, and leave no traces. Maybe he was bragging, maybe it's bravado, but there's probably a kernel of truth to what he was saying. The advantage for open source software is that it is transparent. So you can see the code and see the vulnerabilities. And there are, in fact, many experts who will help you identify those vulnerabilities and address them. So it provides the opportunity to know about those security vulnerabilities, which may not exist when you're dealing with closed source software because you simply can't see the source code. So at some level, you have to trust the organization that's produced closed source software, whereas with open source software, you can build that trust through much more of an open community process that's transparent. So what kind of resources do we need to help GHU remain a leader in this space? Well, that's a very good question. And I will say that I'm pleased to note that we are getting support certainly from the libraries where the OSPO is based. We've actually gotten some support from the Provost's office recently. But those understandably will be focused on Hopkins, the lens of Hopkins. In order to be a leader in this space, I think we need resources to support the organizations I identified in that diagram, which showed the different entities coming together, this one right here. This is many of the things launched out of Hopkins or Hopkins is connected to them directly, but these are intended to be global. These are intended to be much more broad and widespread. So if I can walk through this diagram quickly, imagine I'm an individual researcher and I'm interested in open source. I'm working on a proposal where I have an open source component. OSPO++ is a good place to look at something like that. But if I'm an organization or an institution trying to build an OSPO, you might want to work with the Moss Labs group because they have the expertise about how to put this together in an institutional context. And then I look at the Institutes for Applied Open Source as multiple universities coming together to work on a problem. And then this idea of a company or whatever the right name is, Trusco, is taking the products of those large cooperative grants and making them services. I've been involved and I've led these large cooperative grants, And it's that last mile bandwidth that is an issue. We can have great ideas, and universities are really amazing organizations to generate and create ideas and take them to a certain point, but that last mile piece is a very difficult one. So I think that if we can get resources to flesh out these organizations and the interconnections with them coming out of Hopkins, that would be a great way for us to keep being a leader and have a model OSPO and the kind of work that I've described here today, and also be an originator, initiator, and leader in this broader picture that I'm showing here today. Could I speak a bit more toward the methods of organization across the open source ecosystem that my office is working on? Yeah, so that's a very good question. In the operational sense, I talked about the OSPO. What's challenging is if I asked, what are all the open source software at Johns Hopkins? I can't get a very clear answer on that. So we're beginning with foundational questions like, what is the inventory of open source software? And we are using tools like a GitHub enterprise account. If you're familiar with GitHub, it's a branded software repository. But the enterprise account is one that provides some tools to help work at an institutional level. And we're trying to persuade people to join the enterprise account because it makes it easier for us to address this kind of question. There's a group called Liturgia that builds analytics or dashboards around software that's been identified. We have a grant from the Sloan Foundation to run what's called the Free and Open Source Contributor Fund, voting effort at Hopkins. This is a community-led effort to identify people contributing to open source software in your organization, identifying software which you're dependent on, and then providing funding for those platforms. And that's been a very instructive way to identify open source champions, not only the typical ones like software developers or faculty members, but students and other community members. So we do have some tools that we're putting together to think about what that ecosystem looks like. And again, we're getting help from GitHub, who basically said, what can we do to make it easier for you to figure these things out? So this is a work in progress, but I'm very encouraged by the early results. How can non-technical people support and move this initiative forward? So there are lots of ways, and I think this is one of the most wonderful things about having an OSPO university, is that idea of who's a contributor is completely up to us to define. So students who go interview, organizations about homeless shelters, they're making a contribution. They didn't write a line of code. They're not CS majors. They're making important contributions. There are ways you can support the organizations that we're involved with, of course. And there are also ways to engage on the diversity front. There's a wonderful group called Outreachy that basically provides internships for underrepresented groups to work in open source software. And these are, in many cases, people who have no prior experience or skills with software development, but are given an internship, given funding, and then basically brought up into the open source community. But there's also, of course, many ways in which you can identify potential ideas, potential partners for us to work with. Talk about this in the forums you operate in, the importance of openness, of open source software as a way of collaborating together. The example I gave about cybersecurity in the refineries, the Biden administration has issued an executive order, and the Office of Science and Technology Policy has a request for information right now asking about ways in which we can build up trust and integrity around, federal infrastructure. So these are pathways to get the message out. In areas of the world without a strong digital infrastructure, what steps would make the biggest immediate impact? So this is a really interesting question, because one of the points that I'll make about this rebooting the planet is these are also moments where organizations or countries that previously we hadn't thought of as being in a leadership role can leapfrog. There's a tremendous amount of work, for example, happening in India around open source software, from the government to the universities to organizations, philanthropic organizations, and so on. And they are doing things like working on digital identity and digital payments in a way that we may not even be doing in the United States. So there are ways in which fundamentally people who've not, and institutions and countries who've not been in leadership positions, if they're willing to challenge the assumptions about how you pay for things, how you build software infrastructure, how you identify people without violating their privacy, and so on. Those are ways for these folks to leapfrog in some fundamental ways. So I think the question is right on the mark, that infrastructure is necessary to make this happen. But because digital infrastructure is still relatively new, and there is not a clear established ecosystem around it, there are opportunities, even if you don't have an existing strong base right now. What percentage of open source software are grant funded versus corporate funded? That is a great question. I wish I knew the answer. I don't know the answer to that. What I do know is that the corporate sector has become very engaged in open source software, and there are places like the To-Do Group where you can literally see contributions to open source software by company and by sector and things like that. In terms of the grant space, again, you raised a really good question. I get this question from federal funding agencies. And I don't mean to make this sound too business-like, not that that's necessarily a bad thing, but they're asking questions around return on investment. We provide billions of dollars of federal funding to universities. Much of that is going toward open source software development, yet we don't know what that looks like. So imagine what we're trying to do at Hopkins, or are doing at Hopkins, and that institutional level of what software we produced, who produced it, was it a grant funded effort, so on. We want to do that at all the universities that are receiving grants, not only for our own institutional sake, but also to identify potential partnerships, but also flag or signal to the federal funding agencies, this is what you're getting for the funding that you're putting forward. And are there ways you'd like to adjust that? Are there ways you'd like to do some matchmaking? And then, as I pointed out, I think that universities, companies, and governments need to work together. That was actually one of the really important aspects of how the internet and even the web were developed. It was sort of that triad of those three types of organizations working together. And I think we'll need that with open source software as well. So I'm told that there are no more questions, but I do thank you very much for the questions that you did offer. They were fantastic. I appreciate your time and attention. I hope this gave you something new to think about in terms of open source, not only as an object or a noun, but as a verb, as a way of working together. And if you have follow-up questions or comments or ideas, I encourage you to email the Hopkins at Home folks, and they will route them to me, and I promise I will get back to you. With that, I wish everyone a good afternoon or morning or evening, depending on where you are in the world. And I think we'll close the session for today. Thank you.